Right. Then let's start the discussion of Memory Booster Paper 3. So there are only 10 MCQs to discuss. So let's quickly finish this one. Right. Question number 1. Electrons are emitted from a metal surface when light falls upon the surface of the metal. Energy of photons in light is transferred to electrons, and if that energy is sufficient to overcome the nuclear attractive forces, then that electron can be removed as a photoelectron, right? The minimum energy required to remove the electron varies from the metal to metal. The energy required to remove electrons from the surface of iron metal is 4.06 10 to the power 5 joules per 1 mole of electrons. So they have given the required energy to remove electron from the metal surface is 4.06 10 to the power 5 joules per 1 mole of electrons. The minimum frequency of light that would provide photoelectron is, right? Then you know the equation that we use, equal h nu. According to the Planck's theory, energy of a photon is directly proportional to the frequency. So since they're asking about the frequency, let me use this equation directly. So we don't have to go for the equation equal h over lambda. No need. Because they're asking about the frequency, right? So this is what they ask. Then the next thing is, they have given the energy of a photon mole, right? 1 mole of electrons. Then I can use here E mole equals to h nu capital L, Avogadro number, right? Then we have to find out the frequency, right? E mole divided by HL. So what is the energy they have given? 4.06 10 to the power 5 joules per mole. This is the energy. What is the Planck's constant? 6.626 10 to the power minus 34 joule seconds. Avogadro number 6.022 10 to the power 23 per mole. Per moles will cancel off, joules will cancel off. And here we have 4.06 10 to the power 5. And I taught you that Avogadro number and Planck's constant, that multiplication is always equal to 39.9. Remember that. Especially in these kind of MCQs, that will be very useful. Now, you don't have to use the logarithms in here. Look at the values they have given. Answers 9 into 10 to the power 15 and 4 into 10 to the power 15. 0.1 into 10 to the power 15. 2 into 10 to the power 15. Sorry. Then 1 into 10 to the power 15. So these are the answers they have given. So except this one, others are not containing decimals, whole numbers. So therefore nothing to worry. We can get the round of values, approximate answers. 10 to the power minus 34 plus 23. 1 here minus 11. And here we have per second. So I can write down this one as 4.06 10 to the power 5, 3.99 10 to the power minus 10 per second. Students, can't we say approximately 4.06 divided by 3.99? So this is actually 4.0. 4.0. So we can cancel this one, right? Then the answer is 1. 10 to the power minus 10 will go for the numerator as 10 to the power plus 10. Then 10 to the power 15 per second. Per second means we can say hertz. 1 into 10 to the power 15 per second, or else hertz. Can you understand? So I didn't use the logarithms here. You don't have to use the logarithms. You have to use the logarithms where it necessary. Just imagine we are doing the calculation in the essay paper, and then we have to give the accurate answer. Now here I look at the answers. All the values are whole numbers except the third one. Third one is also easy. We can write down that one as 1 into 10 to the power 40. Got it? So therefore, try to understand here. This is the way. Raise your hand those who got the answer for the question number 1 as the fifth one. Before I do the calculation. Raise your hand those who got the answers. Right. Question number 1, answers number. Question number 2. Consider the following statement. Energy absorbed or emitted from atoms are quantized. Students, this is actually quantum theory, right? So who talk about the quantum theory first? What should be the answer? Energy absorbed or emitted from atoms are quantized. Who discuss about the quantum theory? Max Planck. So therefore, question number 2, answer should be second one. Okay. So these are first term test examination questions. Remember, most of the questions here are extracted from the school term test papers. So then you can expect these kind of questions in your first term examination, right? For that only now, from now onwards, we are preparing, right? Third one. Which of the following statement is false? Let's see. Properties of cathode rays do not change according to the gas filled in the emission tube or the substance used as the cathode. Yeah, that's true. Eh? We have discussed that one. Under the properties of cathode rays, we have discussed cathode rays are not depending on the metal that we are using as the cathode. Cathode rays are not depending on the gas that we have used in the cathode ray tube, whatever gas, hydrogen, helium. Always cathode rays means what? Electrons. And cathode rays, electrons are common particles for each and every element or any substance. So therefore, properties of cathode rays do not change according to the gas filled in the emission tube or the substance used as the cathode. That's true. Positive rays produce shadows of objects kept in their path. That's correct. Cathode rays, positive rays also behaving as cathode rays, right? They are traveling in a straight line. So those are also kind of radiations. So therefore, they can produce a shadow of object, right? Number 3, cathode rays move with the velocity of light. Is this correct? Cathode rays are moving with the velocity of light. Is that correct? No. Then tell me what is the velocity of cathode rays? I would say beta radiations. Tell me what is the speed of the beta radiations that I gave you in the table. Alpha rays are 10% of velocity of light. Beta radiations, cathode rays, electrons, traveling? Yes, 90%. 90% of velocity of light. It is not velocity of light exactly. So that statement is wrong. Third statement is wrong. I think that should be the answer. Particles present in the nuclei are called nucleons. Correct. Together, protons and neutrons are known as nucleons. Number 5. Mass of an electron is 1 over 1837 times as the mass of a H plus ions. Can you remember we took the ratio between mass of a proton, mass of electron divided by mass of a proton. So this is actually 1 over 1837. So we can say that mass of electron, this is equal to 1 over 1837 for mass of a proton. So proton means we know that H pluses. So therefore I can write down here mass of H plus, because proton H pluses are both. So the number 5 statement is also correct. Nothing wrong with that statement, right? So question number 3, answer 3. Raise your hand those who got the answers correctly for question number 3. Good. Number four. Number four is related to the gold foil experiment. Let's see. Majority of alpha rays move without being deflected. Is that correct? Majority. Is that true or false? Majority of alpha rays move without being deflected. Yeah, that's true. Right. So from that only, Rutherford, he decided that most of the space in the atom is empty. Can you remember the three major observations? Majority of the particles went through the gold foil without any deflection. Some of the alpha particles deflected by small angles, and some of the alpha particles deflected by large angles. Some of the alpha particles bounce back again. Can you understand? So therefore, we can say that here, majority of alpha rays move without being reflected. That's correct. Electrons move in constant orbitals. In gold foil experiment, we didn't discuss that kind of thing, right? So we didn't properly discuss about the location of electron. Okay? So therefore, so this should be the wrong statement, but let's go for the other things also. It proved that an atom contains a large empty space. Yes, that is the main conclusion. A positive charges are accumulated in a single place of an atom. Yeah, at the center of an atom, there is a positive charge. That's correct. When an alpha particle comes near the nucleus, they move by getting subjected to a large deflection. That means they are telling that the repulsion forces are occurred by large deflections. Yeah, that's correct. Because some of the alpha particles win by large angles, obtuse angles. Some of the alpha particles bounce back, which are directly coming toward the nucleus. So therefore, that statement is correct. Question number 4, answer should be second one. Raise your hand, those who got the answer as the second one. Right. Okay, are we done? So question number 3 and question number 4 are easy. Second one is also very, very easy. So those are some theories that we learned. Again, question number 5 is a calculation from the de Broglie's wavelength, right? So velocity of particles with a mass 3.313 10 to the power minus 28 grams, and the velocity they have given 1 into 10 to the power 4 meters per second. De Broglie wavelength of the particle is nanometers. They are expecting the answer from nanometers. Let's see. And here also you can see that all the values are 2, right? Then we don't have to use logarithms. What is the de Broglie's equation? Lambda equal h over p. Lambda equal h over mv. So here they have given, they're asking to find out the de Broglie's wavelength. Planck's constant is 6.626 10 to the power minus 34 joule seconds. And the mass of the particle is 3.313 10 to the power minus 28 grams. I will convert that one into kilograms. Then you have to divide that one by 1000. That means multiplied by 10 to the power minus 3. So therefore kilograms here. And the velocity is 1 into 10 to the power 4 meters per second in this. So joules means what? Joules means Newton meters. Newton means kilograms meter per square second. And here meter. And kilogram meter squared per second squared. So here 1 and here 2. Then 10 to the power 4 is going there, 10 to the power minus 38. Then we have 10 to the power minus 31, minus 38, minus 7. And all the units will be cancelling off. So therefore, answer will be in meters. So this is the answer. Lambda in meters. But remember, we have to get the answer in nanometers. So therefore, what I'm going to do here, I'm going to put nanometer unit here by adding 10 to the power minus 9. How is it possible? By adding 10 to the power plus 9. Students, we know that nano means 10 to the power minus 9. If I multiply that one by 10 to the power plus 9 again, then you can see that no issue. So cancelling off and 1 is there, right? So you can convert meters into nanometers by multiplying 10 to the power 9. By multiplying 10 to the power 9. Then lambda equal 2 into 10 to the power 2 nanometers. So the answer should be, question number 5, answer should be third one. Raise your hand those who got the answer as 2 into 10 to the power 2 nanometers. Very good. And do you have any doubts here? Tell me, students, if you have any doubts in this calculation. If you have any doubts, put your doubts in the chat box. No. All clear, right? Okay. Then shall we go to the next calculation? Number 6. Question number 6. Chlorine contains two isotopes. Chlorine 1735, chlorine 1737. If mean relative atomic mass of chlorine is 35.5, the percentage abundance of them respectively are. Students, this is the first isotope calculation that we did. Can you remember? In the theory class, this is the first calculation that we did. But here they are not asking the average relative atomic mass. Average relative atomic mass is given, and they are asking what are the relative abundances of these two isotopes. Chlorine 1735, and here we have chlorine 1737. Let me take the relative abundance of this chlorine 1735 is X, and this should be 100 minus X as a percentage. Then average relative atomic mass equals to 35 into X plus 37 into 100 minus X divided by 100. So the answer, we know that the average relative atomic mass is 35.5. Then 35X. You can shift 100 to the left side, then 35.5 multiplied by 100, 3,550. And here 35X, 3,700 minus 37X. Then we have 3,700 minus 2X, 3,550. Then we have 2X equal, what is the answer? 150. X equal 150 divided by 2, that means 75. Then we can say that relative abundance for chlorine 1735 is 75%, and this one is 25%. So in the correct order, answer should be 75% and 25%. Question number 6, answer should be second one. Raise your hand those who got the answer for question number 6 as the second one. Good, very good.
Abdullah, bring the tab. I have a class.
Right, okay. Are we done? If you have any doubts, put your doubts in the chat box. Question number 6 related to the isotopes. Then question number 7, a very easy question from electromagnetic radiations, electromagnetic spectrum. Which of the following electromagnetic radiations has the highest wavelength? So can you remember the order of the electromagnetic spectrum? Starting from EV and radio waves, radar waves. Radar waves, microwaves, infrared, visible light, UV, X-rays, gamma rays. Right? The students, you know that for this direction, energy and the frequency increasing. So the highest energy belongs to gamma radiation. And tell me for this direction, for upward direction, lambda wavelength increase. Lambda wavelength increase for upward direction. So therefore, according to the given answers, they have given ultraviolet, visible rays, infrared, microwaves, radar waves. They're asking the highest wavelength. So highest wavelength belong to radar waves. Question number 7, answer should be number 5. Raise your hand those who got the answer. That's very easy. Huh? Not difficult. Consider the following nuclear reaction. Question number 8. Right. Now, I'm going to ask you a question. Have you learned this nuclear reaction before? Have I taught you this one before? If it is yes, where did I teach you this one? This nuclear reaction. Here. I have taught you this one, right? Where? Where did you learn this one? This is the nuclear reaction which is taking place in what? Yeah, Harini, correct. No, I need exactly where we learn. Yes, Misra, your answer is correct. Discovery of what? Discovery of neutron. So this is the experiment conducted by Chadwick in order to find out the neutron. So the experiment is, we have beryllium sheet, beryllium 49. Then alpha particles are striking on that beryllium sheet. Then from the other direction, we can see carbon 612 isotopes and neutron. So this is the experiment that we discussed. So this is a nuclear reaction. And I taught you how to balance a nuclear reaction. When we are balancing a nuclear reaction, remember students, you have to check these mass numbers. Summation of mass numbers in left side should equal to the summation of mass numbers in the right side. 9, 4, 13, 12, 1, 30. Summation of atomic numbers, right? Or else we can say that relative charge. We can take relative charge, right? So 4 and 2, here 6. Right side also the summation should be 6. Then only the reaction is balanced. Can you understand? Therefore, so this is the reaction that you have to remember, right? So beryllium plate is bombarded with alpha particles, then carbon-612 isotope is produced, and uncharged particles are produced, which are known as neutrons, found by James Chadwick. So I hope you can remember this practical, the reaction that we learned, right? So consider the following nuclear reaction. X is a neutron. Answer is third. Question number 8. Answer is. Raise your hand those who got the answer for question number 8 as 3. Okay, good, very good. Shall we move to the question number 9? During a certain nuclear reaction, a radioactive isotope X90-232 has been converted spontaneously to other isotopes of a different element, which is Y87-224. The particles released during the process are 2 alpha particles, 2 beta particles, and 2 alpha particles, 1 beta particle, 2 alpha particles, 1 beta particle, and in the fifth answer they have given 2 beta particles and 1 alpha particle. Okay, let's write down that reaction. Let's write down that reaction and see what will happen. They have given, during a certain nuclear reaction, a radioactive isotope X90-232 has been converted spontaneously into another isotope of a different element. That is Y, capital Y. Atomic number is 87, and here 224. Right, just now I told you that now this spontaneous radioactivity emitted some radiations. We don't know whether it is one type of radiation or 2 different types of radiations are there. So just imagine one is there, one radiation. Just now we learned that when we are balancing a nuclear reaction, the relative charges and relative masses should be equal. So here we have 90, 87. Then definitely this one should be 3. Summation. And here 232 and here 224. Then how much we need? We need 8 more. Definitely this one cannot be an electron, a beta particle. Why? Because beta particle means -1, right? Then if it is only beta particles, there should be a negative value, but it's not a negative value. Then definitely alpha particle should be there. Can we take alpha particles alone? One alpha particle is 2, 4, but here we have 3, 4. Okay. And then there is an issue. What is the combination? Is it only alpha particle, or it is only beta particle, or are there alpha particles and beta particles together? What is the conclusion, students? Just think. What is your idea? If I take beta particles alone, you can see that you will never make +3 here, because this is -1. And here alpha is actually 2, charge is 2. Then always when you take the multiple alpha particles, always that will be an even number. 2, 4, 6, 8 likewise. But this is an odd number. Then you have to understand that alpha and beta particles both are there, right? Therefore, let me write down here alpha 2, 4 plus beta -1, 0. Now again you have to be very careful. Why? If I take one alpha particle and one beta particle, we can't make 90 there. Summation is 89 -1, 88. Then it's not possible. If I take another beta particle, 2 beta particles, then also again that value is reduced. What about if I take 2 alpha particles? Then this 2 should be multiplied by 2. Then 4 plus 87, 91. 91 -1, 9. Then no. What about the mass numbers? 224, here plus 8, and this is 0. Then 232. Then okay. Ne? That means 2 alpha particles and 1 beta radiation emitted by this radioactive substance and produce Y. So the answer should be 2 alpha particles and 1 beta particle. So what is the answer? Question number 9. Answer should be 4. Raise your hand those who got the answer for question number 9 correctly. I want to see that. Okay, right. So there are some students. Right. Okay, I'll explain it again. Definitely. '87 is francium and 90 is thorium. Isotope of thorium, and it is converted into francium. Right, okay. Now, I'm going to explain this one again. Now, they have given a radioactive substance is there. It is emitting some radiations and producing another isotope element, 87, and mass number is 224, right? And then here we can see that then let's assume that there should be only one radiation, one particle. Then in order to balance this one, here 87, then how much we need? 3. And here, in order to make 232, we need 8. So in the answers, they have given only alpha and beta particles. Alpha means 2, 4. Beta means minus 1, 0. Here the value is 3. Then we can't make 3 here because this is a minus value. Just imagine if I multiply this one by 3, then it is minus. then this cannot be only a beta particle. Only a beta particle. It cannot be only a beta particle. Then let's take only alpha particle. The value that we have is 3, but the relative charge of alpha particle is 2. If I multiply this one by 2, multiple alpha particles, always we are getting even numbers. When you multiply when you multiply that one by 2, then you are getting 4, 3, 6, then 4, 8. So likewise, you are not getting odd numbers. Then you have to take the decision. There are two different types of radiations. That means both alpha and beta particles are there. That's how you get the conclusion, right? That's how you get the first conclusion. Now, anyhow, you have to make 90 there. Let's assume that we have only one alpha particle and one beta particle. Take the summation 87, 89, again 88. Then 90 is not made. Even the mass number is not made, 228, they are 232. Then let me take two beta particles. Then minus 2. Minus 2 plus 2 cancel of 87, 90, not balance. Then let me take two alpha particles. 87. For 2 into 2 is 4. Minus 1. 91 minus 1. 91 minus 1 is 90. Yeah, that's balance. So here 2 into 4 is 8. Here 224, 232, balance. Reaction is balanced. So that's how we decide two alpha particles and one beta particle. Question number 9, the answer should be okay. Now let's move to the last calculation. In this, in the in the question number 10, students, they have given energies of first, second, third energy levels of hydrogen atom in the kilojoules are minus 1312, minus 328, and the next one should be minus 146. Okay, all of them are minus values. All of them are minus value. Correct that one as minus 146. Do the calculations quickly. Students, part 2 tutorial is ready. Yeah? So this is your next tut. I'm posting this on Monday, right? With this tut, unit number 1 is over. Some of the questions are also there. Question number 10. First, second, third energy levels of hydrogen atom. Energy values they have given minus 1312 kilojoules per mole, minus 328 kilojoules per mole, minus 146 kilojoules per mole. Students, which one has the highest energy? Is it n equal 1? Which energy level has the highest energy? Third one, right? We know that this is a negative value is lower. So we know that when we consider minus 2 and plus 2. So, sorry. Now we have minus 2 and minus 5. So we know that minus 2 is larger than minus 5, right? So number line. Okay. So therefore, this is lower than these two values. And the largest value is this one. Now they're asking here the minimum frequency of the wave which could ionize a hydrogen atom is. Minimum frequency of the wave which could ionize a hydrogen atom is. Minimum frequency. Now we know that, students, how many electron transitions possible here? Now just imagine the electron in the hydrogen atom is in the first principal energy level. Now ionizing means we know that electron is ready to move. According to this diagram, we have only 3 energy levels. Then how many transitions possible? N equal 1 to 2, right? That electron can jump from first principal energy level to second principal energy level. And then there is a chance to jump from 1 to 3. Tell me, students, in which electron transition a large amount of energy is absorbed? Let me take this one as delta E 1, this gap, and I'll take this one as delta E 2. Which one has the largest energy gap? This one or this one? Delta E2. As you can see here, delta E2 is having a larger energy than delta E1. Now here, now listen to this one very carefully. Listen to this one very carefully. That electron can ionize by jumping to the second principal energy level or to the third principal energy level. They are asking here the minimum frequency of the wave. Minimum frequency of the wave. Energy is absorbed. No. These are the energies. If the energy is in this way, how that frequency is behaving? We know that according to the Planck's theory, energy directly proportional to density. If energy increasing, frequency is also increasing, right? Yeah, I'll send you that one. I'll send you that morning class recording. Now listen to this one. Now forget about that one, right? Now we are in the paper discussion, right? Don't worry. This is energy. Energy directly proportional to the frequency. When energy increases, frequency is increasing. So they are asking when that hydrogen atom is ionizing, in which wave, in which energy radiation, the minimum frequency is absorbed. Delta E1. And frequency wise, I can tell that delta nu 2, delta nu 1. When the energy is lower, frequency is also lower. Then this is the minimum frequency. Ne? This is the minimum frequency. I write down this one without delta. This is the minimum frequency. So the minimum frequency is obtaining the electron transition 1 to 2. Raise your hand those who understood the concept that I now taught you. Tell me if you have any doubts. මං කියපු දේ ඔයගලන්ට තේරුණාද? What are the doubts you have? Now, after learning hydrogen emission spectrum, we are going to discuss these kind of many questions. You have to answer for this question very carefully. Tell me if you have any doubts. Right. That means all clear, right? So then you have to understand here the minimum frequency is here. Then you have to find out that minimum frequency value. How do you find out that one? They have given the energy, right? So then I can find out delta E1, that is the minimum energy. Delta E1, that value should be. So I can take minus T28 minus 1312 kilojoules per mole. Now you can find out the energy difference. Now you can calculate how much of energy absorbed by that electron in that ionizing process. 1312 and here 328, take the difference. This is plus and this is negative for here and here 9. So the answer is 984 kilojoules per mole. This is the relevant energy. Now we are asked to find out the frequency. Then you can use the equation equal. And one more thing, students, they have given the energy for per mole, right? They have given the energy per mole. Then E mole H nu capital L. When we are calculating the energy of one electron, we can use equal H nu. Since we are finding for 1 mole, we can multiply that one by Avogadro number L. Mu equals to E mole divided by HL. What is E mole? 985. Shall I convert that kilojoules into joules? 10 to the power 3 joules per mole. Avogadro number and the Planck's constant multiplication is there. Planck's constant is this value and Avogadro number is 6.022 10 to the power 23 per moles. Joules cancel off, per moles will cancel off. Then here 984 divided by 39.9. Right? Here we have 10 to the power minus 11 and here 10 to the power 3, 14 per second. That means hertz. Now do the simplification. Take the log table and do the calculation. Since they have given decimals, I'll do that one using the log. 2.984 9930 399 6010 1.3920 3920 14 hertz or else 2.466 10 to the power 15 hertz. Do we have this kind of an answer? Did I make any mistakes in the calculations? No. $984. Raise your hand those who got the answers 2.466 for this question. Any different answers? Raise your hand, those who got the answer like this. Sandamini and Umar, you both got the answers. If you got any different answers, put your answers in the chat box. Fifth one, 3.29. The minimum frequency of the wave which could ionize a hydrogen atom is even if you use this energy gap also, we are not obtaining the answer, right? Between 146, then we have another value. Right, okay. It doesn't matter. Take this one as old. Question number 10 is old. This is the correct way of doing the calculation and answer, but this answer is not given in the options. Take that one as old. It's okay, fine. Raise your hand those who got this answer before I do the calculation. I want to know that. Raise your hand those who got the answer like this before I do the calculation. Right, okay, good. So if we put 33.99 and divide 984 by 3, is it wrong? No, we can't take like that. No? So when we divide 39.984 by 39.9, that answer should be 24 point this one. So if it is 3, that is wrong. Okay, Anjali, we can't take like that. Right? Right. So this is the third paper, memory booster paper 3. Anyone here got 10 out of 10? Please raise your hand. Anyone here? Oh, wait. How many are there? Umar, Sandamini, Krishna. Okay, good. How many of you got 9 out of 10? 9 out of 10? Akira, Harini, Vinudi, Amani, Kelly, Ayman. Okay, good. There are many. 8 out of 10? Okay. Good. There are many. Yeah. Answer for the last one is all. That means that is a free mark. Okay. Because the correct option is not given. Right. Students, what are the doubts we have in this memory booster paper? Any doubts that you have? No. All clear? Yes, we have to do that exercise. Yes. First of all, tell me, do you have any doubts here? Right.